let's go back to this slide again. The reason why I put the normal distribution in between the negative skewness and the positive skewness, and in between the negative and positive kurtosis, is because a normal distribution is halfway between a negative skewness and a positive skewness, and it's halfway between a negative kurtosis and a positive kurtosis, because here we have a peak at the right end, here we have a peak in the middle, and here we have a peak at the left end, and here we have a peak that's low, here we have a peak that's high, and here we have a peak that's somewhere in the middle. So actually you would say that a normal distribution has no skewness and no kurtosis. So a normal distribution is actually the absence of skewness and kurtosis. A normal distribution has both no skewness and no kurtosis. And there's a value that can actually be calculated with a formula to measure the amount of skewness or the amount of kurtosis in a set of data. And we won't go over the formula for skewness and kurtosis, but we'll talk about what the value shows. If the data is perfectly normal, then the skewness value will be 0. So let's say that this number line right here is the skewness value. Let's move this down. A perfectly normal distribution will have a skewness value of 0. As the skewness value gets further toward the left, it means that the data has more of a negative skewness. So down here and down here, it would mean that if the value comes out somewhere down here, it means that the data is starting to look more like this, like a negative skewness. And if the value is coming out somewhere up here, above 0, it means that the data is starting to look like a positive skewness. So it's pretty straightforward, because if the skewness value comes out to a negative number below 0, it means that the data has a negative skewness. And if the skewness value comes out to a positive number above 0, it means that the data has a positive skewness. And the further the skewness value comes out below 0, the more extreme of a negative skewness you have, or the more dramatic of a negative skewness you have. And the further the skewness value comes out above 0, the more dramatic of a positive skewness you have. And so if the data looks pretty normal, but maybe has a little bit of a negative skewness, then you might get a value close to 0, but a little bit lower than 0, like maybe right here. So right here might be a slight negative skewness. If the data is pretty close to normal but has a little bit of a positive skewness, you would get a value a little bit above 0. And actually kurtosis works the same way. If the data is perfectly normal, then it'll have a skewness value of, it'll have a kurtosis value of 0. If the kurtosis value comes out to a negative number, then you have a negative kurtosis. If the kurtosis value comes out to a positive number, your data has a positive kurtosis. And the further the kurtosis value is below 0, the more dramatic of a negative kurtosis you have. And the further the kurtosis value is above 0 out here, the more dramatic of a positive kurtosis you have. So right here could be a slight negative kurtosis, and right here could be a slight positive kurtosis. So a perfectly normal distribution will have a skewness value of 0 and a kurtosis value of 0. And actually, if the skewness value and kurtosis value are both between -1 and +1, then you could say that the data is at least close to normal. That's the guideline that's used. If the skewness and kurtosis values both fall between -1 and +1, the data is at least close to a normal distribution. Because anything between -1 and +1 is roughly no skewness, and down here anything between -1 and +1 is roughly no kurtosis. So if it has roughly no skewness and roughly no kurtosis, it's close to normal.